In this tutorial, we are going to learn various extruded features in Solidworks. We do so while we make the V block as shown on the screen. We are using Solidworks 2018 version. If you carefully look at this V block, there is no one sketch which can describe all the features that are contained in this part. Thus, we require more than one sketch to generate all the features that appear on this V block. For instance, if you look at it from the right side, we see the true shape and size for the V block, for the trapezoidal cut that we have at the bottom. And when we look from the front view, that's another sketch on the front plane, we see the rectangular slot and the shape of the overall block. We consider the two views, the two necessary orthographic views to get the dimensions needed for modeling this part. We have the simple front view and a simple right hand view. The right side view describes the angle of the V as 90, the trapezoidal cut at an inclination of 60 degree with a height of 30. In the front view, we get the details about the rectangular slot 30 mm wide, 20 mm deep into the part. The foremost thing is the overall block, which has a dimension of 100 along the width, 70 as the height, and having a depth of 85 mm. So before we start modeling this, we develop a strategy to come up with various sketches, the order in which we move ahead in making this part. Let us try to model it the way it is machined on a milling machine. We consider a stock of material, machine it down to the overall block, the size of the overall block, which measures 100 by 70 by 85. So our steps would be to make an overall block which measures the maximum dimensions along the width, depth and the height. Then cut a slot, a rectangular slot from the top face. The third step would be to make a V slot coming in from the right face. The fourth step, to make the trapezoidal cut that comes at the bottom of this block. We start with a new file. From the standard toolbar, select new. We select part document, say OK. Let's maximize the screen. Select the units as millimeters, gram, second. We start with the front plane. Turn on the sketching mode. You may select rectangle under sketch toolbar. We select the type as two opposite diagonals. Start with the origin. The second click on the top right corner. We dimension this to have a width of 100. and a height of 70. We have a fully defined sketch. We then go over the features toolbar and extrude this part using extruded boss base to a depth of 85 millimeter. So we specify 85 in the property manager for extrude boss. Accept this. So we now have the overall block with the maximum dimensions on this part. We now start removing the material to generate the rest of the slots that appear on this block. We start with the rectangular slot coming in from the front face of this block. We go over features, extrude cut. So we would like to subtract some material from this block. Use extrude cut. Select the front face of this block. We have the sketching mode with the two icons here on the top right corner indicating that we are in the sketching mode and our sketching plane is the front face of this block. We go normal to it under view orientation. You may draw a rectangle or you may draw the rectangular slot with the help of lines. You may use line under sketch toolbar and then generate 3 lines, or you may opt for a rectangle and then make a rectangle from the top edge of the block. We may move out of this sketching entity by selecting rectangle again. Zooming out a little and assigning dimension using smart dimension tool under sketch toolbar. Assign a distance of 35 millimeter from the left face of this block, a width of this block as 30 and the depth into the part as 20. This is a fully defined sketch. Let's change the view to isometric. We have made a sketch on the front face here. This sketch is now used to subtract material from the existing block. We go to features, extrude cut. We have started with the sketching plane. To remove the material, we have option under direction 1 as blind. We can specify the depth up to which we need to remove the material, 85 millimeter, or if it is blind, you can even make it slightly less. For example, it is 40. You'll find it going deep to 40 millimeter and then it stops. In our case, to make a V block here, we cut it through all, so we don't need to specify the depth. It has to cut through the entire material. Accept this. We have two features in the feature manager design tree: boss extrude 1 for the overall block, cut extrude 1 for the rectangular slot. We now make the V slot, which is as seen from the right face of the block. So we select the right face. You may turn on the sketching mode or make this face as your sketching plane. Go normal to it under view orientation. Zoom out a little and make the shape of the V using a line command. We go all the way up to the top surface of the block, move out by simply selecting the option select. You may give the dimension as 9 between the two vertical lines. You have the start of this V at a distance of 15 from the front face. The angle between the inclined lines 90. You may adjust this to get it back to the same shape. We have an overall height of the slot as 30. And now to further define the sketch, we add some relations. This V slot is in the center of this block from the right end. So we sketch a center line to make use of symmetry. First define the center line. You may go to add relations, pick up the extreme ends of the predefined lines from the block, add the axis line in there and assign a symmetry relation. Accept. You may now give a similar symmetric relation with the two vertical lines that you have in here with the axis and scroll it down to select symmetry. The same with the inclined lines. And the axis line. We now have a fully defined sketch of the V. We go over isometric view. We have the sketch on the right face. You may go to features, extrude cut. You have this as spline, through all and through all on both sides. So we are having only 3 options here compared to more than 3 in a previous step where we had a closed contour. So if you have an open contour, the V is open from the top. If you have an open contour, you will have just 3 options: line to a certain depth, through all, or through all on both sides. However, if you have it as a closed contour, as was the case in a rectangular slot, you have more than 3 options. You can go up to next, you can go up to a particular surface, and so on. So let's make it up through all. We do not need it in the second direction. I turn off the second direction, say OK, to generate the V slot. The next step is to add the trapezoidal slot at the bottom of the block, and its shape is as seen in the right side. So we select the right face, make this a sketching plane, go normal to it. Let's make the profile of the trapezoid with the help of a line under sketch toolbar. Sketch an inclined line, a horizontal line, another inclined line. Use smart dimension to assign the distance. The start of this from the front face as 15. The height as 13 and the inclination at 60 degree to the horizontal. We have the other inclined line at same inclination, however no dimension is separately given. We assign a symmetry relation. We make use of an axis line. We define the axis line to be midway between the predefined lines of the block by assigning a symmetry relation. Further, we add a similar symmetric relation to the inclined lines and the axis line. We have a fully defined sketch appearing on the right face of the block. Go to isometric view and have a look at the sketch. Let's go to Features toolbar and use Extruded Cut. You have option blind to go deep by 40 millimeter here, as mentioned, as the value given there, or you can increase the distance, or you may select through all on one side. So we uncheck the direction 2. You have the side to cut. As can be seen here, there's an arrow pointing towards the side which is going to get cut. It has to be pointed inward to remove the material that's inside this trapezoid. You may check the box flip side to cut to reverse it, or you may simply select the arrow, double click on it to flip the side. Accept this, and you can change the orientation to isometric again. So we have seen the various features under extruded boss base and extrude cut to make this V block, various options under it. We have got 4 features in the design tree. Boss extrude 1 for the overall block. So let us try to give it a name. If you wish to make any modifications to that, it would be handy if you have a name assigned to it. You may press the key F2 on the keyboard and given the name here as block, or you may click twice on the name of the feature, assign it another name here. It refers to the rectangular slot. Given the name rectangular slot. The third one here, we have it as V slot. Fourth one as trapezoid. Or you can just trapezoid. You may also look at the properties, mass properties of this particular part. You may go over evaluate toolbar. You have mass properties. Under it you have options. You have another dialog box for mass property options opening up. You have the density given here as 0.001, and if you look at the mass over here from the density 0.00, this is up to 2 decimal places. However, you still have a value after that as 1. Doesn't matter if it doesn't show up here, but it does the calculation with the value 0.001. You may change this by using custom settings. You may assign the unit here, millimeters, 2 decimal places. We can increase this to 4 and assign this value here 0.0078, close to that of steel material. Say OK, and you will find the details updated here under mass properties. You have density 0.0078 grams per cubic millimeter. A mass of this block with the dimensions as assigned is 3,302.1863 grams. An alternate way to assign the material here is to click on the part file or the part name that you have assigned here. go over material and say edit material. You have SolidWorks materials. You have various folders for different grades of these materials. If you pick up steel, you may find steel anneal with a value close to 0.007850. Apply and close. And this is what is the part that you have here. A V block made up of steel. That completes the tutorial on extruded features from SolidWorks.